A hard disk drive, as pronounced as hard disk, hard drive, or fixed disk, is an electromechanical data storage device that stores and retrieves digital data using magnetic storage and one or more rigid rapidly rotating platters coated with magnetic material. The platters are paired with magnetic heads, usually arranged on a moving actuator arm, which read and write data to the platter surfaces. Data is accessed in a random access manner, meaning that the individual blocks of data can be stored and retrieved in any order. Hard disk drives are a type of non-volatile storage, retaining stored data even when powered off. So modern hard disk drives are typically in the form of a small rectangular box. Hard disk drives introduced by IBM in 56. So hard disk drives were the dominant secondary storage device for general purpose computer beginning in the early 60s. So hard disk drives maintained this position into the modern era of servers and personal computers. Throughout personal computing devices produced in a large volume like cell phones and tablets rely on flash memory storage devices. So more than 224 companies have produced hard disk drives historically. Throughout, after extensive industry consolidation, most units are manufactured by Seagate, Toshiba, and Western Digital. Hard disk drives dominate the volume of storage produced exabytes per year for servers. Though the production is growing slowly by exabytes shipped, so sales revenues and unit shipments are declining because the solid-state drives, SSDs, have higher data transfer rates, so higher real storage density, somewhat better reliability, and much lower latency and access time. So the reverse of SSDs, most of which use NAND flash memory, slightly excess to use for hard disk drives. Flash storage products had more than twice the revenue of hard disk drives as 2017, though SSDs have 4 to 9 times higher cost per bit. They are replacing hard disk drives in applications where speed and power consumption, small size, high capacity, and durability are important. Cost per bit for SSDs is falling, and the price premium over hard disk drives has narrowed. So the primary characteristics of an hard disk drives are its capacity and performance. Capacity is specified in unit prefixes corresponding to the powers of 1000. So a 1 terabyte drive has a capacity of 1000 gigabytes, where 1 gigabyte equals to 1 billion bytes. So typically some of an hard disk drive's capacity is unavailable to the user because it is used by the file system and computer operating system, and possibly inbuilt redundancy for error correction and recovery. Also, there is a confusion regarding storage capacity signs. Capacities are starting in decimal gigabytes, powers of 1000 by hard disk drive manufacturers, whereas the most commonly used operating system report capacities is powers of 1024, which results in a smaller number than advertised. So performance is specified by the time required to move the heads to a track or cylinder, average access. This means average access times. So the cylinder adding the time it takes for the desired sector to move under the heat. This means average latency, which is a function of the physical rotational speed in revolutions per minute. And finally, the speed at which data is transmitted. This means data rate. The two most common form factors for modern hard disk drives are 3.5 inch for modern desktop computers and 2.5 inch primarily for laptops. So hard disk drives are connected to systems by standard interface cables such as PATA, this means parallel ATA, SATA, this means serial ATA, USB or SAS, SAS in here, or serial attached SCCI cables. How a hard drive works. In your computer's hard drive, there aren't really any iron nails. there is just a large shiny circular plate of magnetic material called a platter, divided into billions of tiny areas. Each one of these areas can be independently magnetized to store 1 or demagnetized to store 0. Magnetism is used in computer storage because it goes on storing information even when the power is switched off. If you magnetize a nail, it stays magnetized until you demagnetize it. In much the same way, the computerized information or data stored in your PC hard drive stays there even when you switch the power off. A hard drive has only a few basic parts. There are one or more shiny silver platters where information is stored magnetically. There is an arm mechanism that moves a tiny magnet called a read-write head back and forth over the platters to record or store information. And there is an electronic circuit to control everything and act as a link between the hard drive and the rest of your computer. The pluggers are the most important parts of hard drive. As the name suggests, they are disks made from a hard material such as glass, ceramic, or aluminum, which is coated with a thin layer of metal that can be magnetized or demagnetized. A small hard drive typically has only one platter, but each side of it has a magnetic coating. Bigger drives have a series of platters stacked on a central spindle, with a small gap in between them. The platters rotate up to 10,000 revolutions per minute, so 10,000 RPM per minute. Actually, no, 10,000 RPM. RPM means per minute, revolutions per minute. So I don't have to say after RPM after revolutions per minute. So the read-write heads can access any part of them. So they are rotating the 10,000 revolutions per minute to read-write heads can access any part of them. So there are two read-write heads for each platter, one to read the top surface and one to read the bottom. So a hard drive that has 5 platters will need 10 separate read-write heads. The read-write heads are mounted on an electronically controlled arm that moves from the center of the drive to the outer edge and back again. To reduce wear and tear, they don't actually touch the platter. There is a layer of fluid air between the head and platter surface. So how reading and writing data works on hard drives? So the most important thing about memory is not being able to store information, but being able to find it later. Imagine storing a magnetized iron nail in a pile of 1.6 million identical nails, and you will have some idea how much trouble your computer will get into if it didn't use a very methodical way of filling its information. So when your computer stores the data on its hard drive, it doesn't just throw magnetized nails into a box, all jumbled up together. So the data is stored in a very orderly pattern on each platter. Bits of data are arranged in a concentric circular paths called tracks. Each track is broken up into smaller areas called sectors. Part of hard drive stores a map of sectors that have already been used up and others that are still free. So in Windows, this map is called the File Allocation Table, or FAT. When the computer wants to store new information, it takes a look at the map to find some free sectors. Then it instructs the read-write head to move across the platter to exactly the right location and store the data there. So to read information, the same process runs in reverse. So how does an electronic computer manipulate all the magnetical nitty-gritty in a hard drive? There's an interface, so a connecting piece of equipment between them called a controller. This is a small circuit that operates the actuators, select the specific tracks for reading and writing, and converts parallel streams of data going from the computer into serial streams of data being written to the disk, and vice versa. Controllers are either built into the disk drives on circuit board or part of the computer's main board, motherboard. With so much information stored in such a tiny amount of space, a hard drive is a remarkable piece of engineering. That brings benefits such as being able to store 500 CDs on your iPod, but drawbacks too. One of them is that hard drives can go wrong if they get dirt or dust inside them. A tiny piece of dust can make the read-write head bonds up and down, so crushing the platter and damaging its magnetic material. This is known as the disk crash or heat crash, and it can cause the loss of all the information on a hard drive. So a disk crash usually occurs out of the blue without any warning. That's why you should always keep backup copies of your important document and files, either on another hard drive, on a compact disk, DVD, or flash memory disk here. So what's the difference between hard drives and SSDs compared? Hard drives are tried and tested, are capacity and cheap, but they have plenty of drawbacks too. One issue is the amount of time it takes for the read-write head to get itself to the right part of the disk to access the information you want. The heft of a hard drive and its relatively heavy power consumption are also problems. Especially in mobile devices such as tablets and smartphones, reliability is another issue. As you will have gathered from what you just learned, a hard drive is a wonderful bit of precision engineering with plenty of interactive moving parts. It could easily work for 20 years with no problems at all. Then again, if you ever suffered a hard drive heat crash, a serious mechanical breakdown caused by something like dirt on one of your hard drive's platters, or a sudden mechanical shock, and lost everything you have stored, even stored on your computer, there's no reassurance. You will know a hard drive will instantly fall out of love with you if you treat it with less care than it deserves.